Good evening, everyone. My name is Arush Nigam, your host for today's session. I welcome you all for the second day of AWS Summer Wave 2021, where you will learn and explore AWS from scratch. We as AWS Cloud Community LPU always believes that success is not the destination, but gives our best for achieving success in the goal. So here we have a 3-day series of webinars, and today is the day 2. If you have missed the day 1, no worries. It's available on our YouTube channel itself. All the webinars are directly being taken by the industrial experts who have been into this domain for a very long time. Let me give you a short brief of our community. AWS Cloud Community LPU empowers you all willing students and shape a community where everyone is responsible, dedicated, and also ready to explore the experiment and new possibilities using AWS platform. This community aims to reach out to the maximum number of students, making them aware of AWS. Thus, to guide the students and make them community much stronger, frequently workshops and competitions are organized by the members of the community. These workshops teach attendees how to make the efficient use of this amazing platform, which is AWS. So moving on, as my co-host Brahmajit must have already told you about AWS Summer Wave yesterday. But in case if you missed the last session, no need to be worried. I will be telling you about everything about AWS Summer Wave again. So in the day 1 means yesterday we had discussed about path for cloud to DevOps, which was taken by Aditya Soni sir. He took live demonstration on introduction of continuous integration and continuous delivery. You can check the recording for the same in our channel. And day 2 means today we will be seeing introduction to serverless database, which will be taken by Mr. Anurag Kale sir. He will be also showing live demonstration on Amazon Aurora Serverless and DynamoDB. And on the day 3, which is on 20th April, we will be seeing path to AWS Airflow by speaker Shashank Mishra sir. He will be showing live demonstration on AWS services for simple ETL pipelines. And the most interesting part, the perks. So e-certifications will be provided to all the registered attendees. The condition is you need to fill the feedback form, which can be provided anytime during this session. It can be in the middle, it can be at the end. So you need to be attentive all the time, and you need to fill this form within 30 minutes of getting the link. So kindly be active. And the second thing is highly qualified and experienced industry professionals will be presenting and get a chance to learn from industry experts. And the most exciting part is this whole things are free of cost. So guys, moving on, let me introduce our speaker for today. It is said that those who don't jump will never fly. Our today's speaker is a live example of this saying. He is cloud architect currently with 6.5 plus years of experience in the IT industry. He is a co-organizer of AWS UG Pune and also an AWS community builder. He started his career as a database developer working in startups, which eventually helped him gain cloud exposure, and he made his move to cloud 4 years ago. He is active on LinkedIn and Twitter, where he shares his journey and tips for a career in cloud. In his free time, he likes to read books, hike, and listen to various forms of music. Presenting to all, Mr. Anurag Kale sir. Make a huge round of applause for him. You can share your excitement emojis, you can share your clapping hands section. So welcome, sir. We are happy to have you on the board.
Thank you very much. Thank you for the generous, how would I say it, generous introduction. I'm very excited to share what a basis, a platform, a small, how would I put it, starting point in terms of databases and how databases you can leverage these databases on cloud so that you have a platform to experience the journey and take the path as you move ahead. So thank you very much. I'm very excited to be here.
So over to you, sir.
Okay, perfect. So let's start by, I'm going to quickly share my screen and share. Okay, awesome. Let's do a slideshow from the beginning. Awesome. So let's talk about what we are going to do today. So what I'm going to do is I'm going to introduce you to the world of databases first, and then we will look at how serverless databases are acting as a bridge or acting as a way that we can leverage cloud to the best. So who am I? So like you have already been introduced. My name is Anurag Kale. I am currently working as a cloud solutions architect or a cloud architect. So in my day-to-day life, I interact with the various customers, try to understand their workloads, try to understand how they are using various things on premises, help them make decisions to choose the right thing in the cloud, the right service in the cloud, and then help them create and implement the architecture. So here's the agenda for today. So what we are going to do is we will take a step back first and try to understand a little bit about relational database modeling system, relational database management system. I'm sorry. We will take a small introduction to NoSQL databases. Then we will look at the anatomy of running a database. So by this, what I mean is we will spend some time and try to understand how industry is running databases at this moment, whether be it on premises or be it in cloud. Then once you get the base understanding of how the database runs, we will look at what serverless database brings to the table, right? Because if there was nothing wrong with the way the databases were running, there was no need to bring the concept called as serverless. So there must be some limitations, there must be some problems, there must be something that would have helped the industry to pivot away or move away or look at a different concept, and that is where the, you could say, notion of serverless database has come from. Then we will have a small demo where we will go into the console, AWS console, and look at AWS DynamoDB. We will look some concepts of the AWS DynamoDB, and we will also look at the relational serverless database called as Aurora Serverless in the database. So the flow is we will try to cover some theory, some PPTs, and at various steps we will take a pause and we will take your questions, and then we will go to the console and look at how things are working in real time. Okay, perfect. Let's get started. So assuming that you all are in colleges, you're in college, you have taken a relational database course. If not, this is a small introduction. So relational RDBMS, which is nothing but a full form, the full form is Relational Database Management System, is based on the relational model which was laid forward by EF Cord. So this was developed somewhere in 1970s, and since then has been the basis of how relational database management system works. So typical examples of relational database that you see around is MySQL database, Oracle database, or PostgreSQL, or Microsoft SQL Server, etc. Right? So the relational database model system is actually based on what we call as entity relationship modeling. So what does this mean? So let's try to take an example. So you guys are generally using, let's say for payments, you're using an app like Phone Pay or Google Pay, right? So if we are looking at an application like that from an entity relationship perspective, an entity is a representation of an object from the real world. So if, for example, if it is Phone Pay, then the person who is receiving money is an entity, the person who is sending money is an entity, uh, the bank which is in which the money is getting transferred is an entity, the money transferred to and transferred from, that is an entity, then the transaction, the amount, is an entity. So what does relationship means then? So relationship means that how these entities are interacting with each others, right? When I say interacting with each other, it means that Can one person send multiple payments to another person? Can one person send payments to only one person? So these kind of uh, interactions that are happening between the entities is called as relationship, right? And when you look at the solutions like SQL Server, MySQL, so they implement these theory by using what we called as tables, and we are using you could say constraints to create a relationship between them. So on the top you see a small you could say example. So in this example we have three tables. There is an employee table, there is a department table, there is an employee department table. So this is a very typical example that has been taken in textbooks and is used to basically make an introduction to relational database world and easy to understand. So basically our employee and department table can be applied to any company. Let's say for example, if you're working in a software company, then you are an employee, and a software company wants to have a list of his employee, know where they are residing and all that stuff. Within a company they have multiple departments, so there is a different list or a different table where there are departments. Now how do I know which employee belongs to which department, right? So it could happen that one employee could be a part of multiple departments. So this, in this particular case, the employee department is an entity, and the way they are interacting with each others is by using what we call as constraints. So one of the constraints that you see here right now is foreign keys, wherein in a third table we are using employee id as a reference, department id as a reference, and then we are using it when and then we are establishing a relationship between them. So what does this mean? In this particular diagram, if we, it means that employee number one belongs to department number one, as well as employee number two belongs to department number one, so on and so forth. So this is a very simple paradigm which has been used for a long time, right? It has been the basis of the lamp stack. So lamp stack has been the stack of development which is very famous from last 25 to 30 years. Lamp stands for Linux, Apache, MySQL, and PHP. So the products like you could say products like WordPress, they heavily use and are heavily developed by using relational database models, and they are using the lamp stack behind the scene. So this is my attempt to basically just give you a very brief overview of relational database management system. Not that you need it, but this is how database system works. But there were, as we hit 2000s, basically, which means that after 1970s, around 40 years, we were able to manage the scale with relational databases. Databases were awesome. uh, they started to hit some limitations. Now these limitations could be overcome by pre-planning, they could be overcome by doing good architecture, but because something that has been built for 30 years and has been working without flaws, changing that would mean that there will be a lot of implications. So people started to make a difference, started to look at different things that can help, and how we can speed up the development, and how databases can scale and basically give you a better consistent performance without making trade-offs, or without basically uh, abstracting away the complexity. So with that particular aspect came into a new concept called as NoSQL databases. Now people generally think when you say NoSQL, it means that there is no SQL the language of SQL, which is used to interact with the relational databases, that is not present. But that's a very big, how would I say, misconceptions. The actual acronym, if you expand it, NoSQL stands for not only SQL, right? So this basically means that you need to have databases for certain use cases where you need to optimize the underlying data structure so that it suits better with your use cases. So this is how NoSQL came into picture, and it was basically created for internet scale. When I say internet scale, basically the pioneers, the people who have worked on these different modeling techniques generally come from very big uh, companies, internet companies like Facebook, Google, because the scale that they were hitting was totally out of the world, totally nothing that a lot of people were facing at that given moment in time. So when we talk about NoSQL databases, right? So we have four broad categories. The four broad categories are document databases, then we have graph databases, we have something called as key value databases, and we have a fourth type called as wide column or sometimes called as columnar databases. So let's try to understand each of them in very brief. So what does let's start with the simplest one. The simplest one in this particular, you could say, uh, array is a key value kind of database. So what does the key value mean? So imagine a lock, right? The one that you put on your doors. So there is one key, and using that key you can unlock that particular door to extract value whatever is present behind the doors. So as simple as that. So if you have the right key, you will be able to extract the right value behind the doors. So that's the concept of key value. So in key value database, what you do is you have an identifier for the row. So that will be a unique name, number, or a combination of characters. Now if you tell the database that okay, I have this key and I need the respective value for this particular key to be extracted from the database. So the database will go and simply, if you have the right key, will give you the corresponding value. So these key value pairs, as you can imagine, it's a simple concept. So if, let's say, to speed this up, like uh, index on your notebook, oh sorry, not notebook, in an index on your textbook. If you want to look for particular topic, you have an index. So you will directly, let's say you are interested in a word, like for example, uh, graph. So you know that the graphs start from G. So what you can do is you can skip A, B, C, D, E, F and directly look at G. So if you have an index which is built on top of keys, you can directly skip anything from A to A to F, and then directly look at graph, and you can fetch the value. When you get that particular value, you'll be able to find that particular value. So this speeds up the retrieval. So key value pair or key value database serves a very important use case of what we called as a cache. So what is a cache? We are going to look at it in a moment, but that is a very good example of how key value pairs, key value stores come into picture. Then we have something called as graph databases. So I'm sure most of you must be using some sort of social media websites, let's say Facebook or Instagram or Twitter or LinkedIn, for example. Now, in all of these social medias, there is a concept called as friend then there is a concept of friend of a friend. Or in LinkedIn, as in LinkedIn terms, it says that you are a first degree connection, you are a second degree connection, you are a third degree connection. So how does that come into fruition, right? So the entire logic of these relationships is established by using graph databases. So each circle that you see on this particular graph represents a small, it represents a node. This node can be any entity. So in a relational, in you could say social media sense, this is your persona, this is your profile. And if you are connected with another person directly, let's say, then you have a direct link to that person. That means you are friend. Now there can be a case where your friend is a friend with another person. Now because you two are connected, this is how Facebook or LinkedIn determines that, okay, because you are connected with person A and person A is connected with person B, there is a possibility that B is also your friend. And that is how they create recommendations. So these graph databases are not only used in relational databases, sorry, not only used in social media, but they are also used to create good recommendation engines. So when you, let's say for example, if you're purchasing toothpaste on Amazon, it says, okay, you might require toothbrush as well. So each, the toothpaste is a node here and a toothbrush is also a node. And depending on how people have been shopping, they will establish a relationship between a toothpaste and a toothbrush. And next time anybody tries to purchase either of these products, they will say, okay, hey, other people's, if they are purchasing toothpaste, they're also trying to purchase toothbrush. Do you want to do the same? So this is how you leverage the graph databases. Third type of NoSQL that we have is document DBs. So a very good example of document DBs and use case of document DBs is, let's say, whenever you are searching for an item on on Amazon, for example. If you say, okay, I want to get a book, The Alchemist, and when you search Alchemist, it, you see on the screen multiple values. You will see, for example, the image, you will see the name of the book, you will see the author's name, you will see a brief description like how many number of pages it has, what are the reviews, what are the different things. So basically, to make these things faster, what you need to do is, for every book you need to keep the value bundled into a single place. So in this example, a book represents a document in the database. So what we do is we write a nested JSON. So basically JSON is a representation of data, and within that particular data we will say that, okay, for anything related to this particular book, this is all the information that you need. So anytime next time somebody searches for The Alchemist, what you can do is you can bring out all the value which is associated with that particular book and show it on the screen. So this way you can have uh, a big chunk of data which would otherwise be distributed in multiple tables in a relational database format in a single call from the database and show it on the screen, making your pages load much faster. Now the last category that we have is the wide column databases. So in wide column databases, what basically it means is, you in relational databases, you store the data in a row format. So every data is stored one, you could say, in horizontal fashion, right? So and each row is identified by primary key. So instead of storing the data in horizontal fashion, wide column stores the data in vertical fashion. So by that, what you can do is you can start treating each column as a separate entity. Now this comes in very handy when you are trying to do some sort of aggregations. When I say aggregations, you see things like on TV that okay, 78% of people are having coronavirus in Delhi. So how did they come up with that number, right? So although this case is very simple, this could have been done by relational databases as well. But imagine a big conglomerate or a big business like Amazon, where they are trying to generate these kind of aggregations, this kind of numbers by crunching a lot of data. So in those cases, it becomes imperative, it becomes very easy to store this data in columnar format, so that you can perform a lot of different logic on top of it, so that you can create value for the business, right? So this is a very brief introduction of to the world of databases. I know I haven't brought the serverless into picture yet, but we are going to get there in a moment. So let's look at, without uh, keeping or without constraining ourselves to a particular way of database, that is relational or non-relational. For example, let's see how typically we run a database for a website or for a business, right? So what we have is, in the start, you see as what you see is a pool. So pool is nothing but a proxy or a place which basically listens on your behalf for people or for services or for different programs that are trying to get in touch with your database. So this connection pool basically hears them out, and it makes a check that okay, whether the server, whether the general regular database is overwhelmed or not. Then it forwards that request to the next layer, which is a cache layer. So this cache layer generally acts as a buffer between your main database and the request. So what you do in cache, you typically store data which is frequently accessed, which is frequently required for any kind of users. To give you some context, let's say when you say amazon.com, then whatever page comes up, that particular page is going to be common for each and every user who is going to hit amazon.com. So this is a frequently accessed data. So instead of every time trying going to the database to fetch those details, we will just fetch it once in cache and keep it there in RAM, that is random access memory, so that you will be quickly able to bring it up on screen whenever there is a request from the pool for that particular data. Now now let's say if the data is not present in a cache, it will happen multiple times. Let's say somebody made a very different kind of a query, somebody is asking on amazon.com for a different kind of thing. Let's say for example they are asking for a very specific book which is written in for example Urdu or Marathi. So now that is not a frequently requested item, so it is not put in cache. So what it does is, once the cache determines that okay, I don't have that value, it passes on that particular mantle to the actual server, and that actual server will then look at that particular query. Then it does the process where it tries to understand the process, it creates a query plan, and it will then send a command to the hard disk where the data is stored, and depending on what and then fetch the value inside the RAM of the server, the database server, do the processing and send it back via the same route to the pool, which then sends it back to the application. So this is how database runs. But you might say, okay, if I have one database, what if that particular server goes down? Now let's say I'm running this server based out of my apartment, for example. What if the power of the apartment is cut? What if the area in which the server is present, the internet goes down, the internet provider is not responding? What if there is a fire? What if there is a catastrophe, any kind of thing? Then your entire application might go down, right? Or if there is a hardware failure, the smps of your server goes blown away, your RAM stops to work, your hard disk stops to work. So anything can happen, right? So what generally people do is they keep a hot backup up and running. So what we mean by a hot backup is basically every time a transaction, every time a data is written to a main server, it is copied over to another server. So in this particular slide, you see a small line separation between them, and we have something called as a main DB and then a hot backup DB. So this particular DB will whatever transaction happens to this DB, they are copied over to the secondary DB. So with this you could say mechanism in place, if a server goes down, what you can do is you can quickly switch over to the new hot backup database, and then you can then look at your main database which went down, bring it up, fix it. Until then, your you could say your people who are using your service are not affected, and they are not they still get the experience that they basically deserve. Then there is another thing. So let's assume that you want to run this particular database at scale. So when I say scale, for example, just again another take an example of any e-commerce platform. The e-commerce platform is running in US. The e-commerce platform is running in India. It is running in Europe. It is running in Singapore. It is running in Japan. So there's a lot of load on your databases, right? So what they do is they create what we called as hot backups. They also create something called as cold backups, and they also create something called as read replicas. So what read replicas generally represent, read replicas generally what they do is they have a server in standby, and like they make a copy of the data to the hot backup database, they also make a copy to another of the data to another you could say hard disk, and you spin up another server. Now this server, the role of this server is to just accept the read only queries. So for anyone who is not making a purchase yet, so there is no transaction, there is no data that needs to be written through, you can use the read only service to take off the load from your main database. So this is how read replicas basically work. And for a big database system running at scale, you can have multiple read replicas. Now these read replicas can be distributed. Let's say for example, if you are looking at something like a flipkart.com in India, they can have main database, let's say in Hyderabad, and they can have read replicas in Delhi, Mumbai, Kolkata, Chennai, and they are all connected by their own network. So by this they will be they make sure that okay, for all the queries that are running just to look at just to look at and making just to look at the items that are present, those are getting proper response, but also anything that is happening as a transaction, if somebody is purchasing it, that is well kept inside the main database. So what does it take, what does it take for a typical company to keep this kind of setup up and running, right? So it requires multiple teams so that you can handle this kind of a database system. So you require people who are specializing in hardware. So somebody who can look at the hardware and say, okay, the hard disk is not working, the RAM is not working, the server is not working, the SMPS is not working. You need to have a person who knows network. So if you have your main database in Hyderabad and a read replica in Bangalore, if they are not able to communicate with each other, why is this happening? Is a router is a switch or a router in between them not working? If it is not working, what is the problem? You need to have an operating system admin, somebody who knows Linux, Unix, or Windows, because on top of these operating systems you are going to run your database. You need to have database administrators who understand the product that you are using for your database. For example, if you are using MySQL, if you are using Oracle, these are two different skill sets. The DBA who does Oracle DBA, Oracle database administration, may not be able to do MySQL administration, because these are totally two different products. You also require database developers, so that they can create the appropriate data model. And then there are application developers who have to fetch those details and show it, basically interact with the database and show it on the screen. Then there is something called as a procurement team. So this team is responsible to make sure that, okay, whatever hardware you require to run this database is always there with you. So it should not happen that, okay, one of the database has blown away, the SMPS is not working. You need to have an SMPS in backup, right? So this is how a traditional setup before cloud used to work. So these are the number of people that you would generally require to keep your database up and running. So this is how tedious it was. Things changed a bit since relational databases have come into picture, and how they have changed, that will be the next topic that we will look into. But until then, we will take a short break and answer any questions that you might have.
Sure, sir. So let's have a small Q&A session with our audience. If you have any question, any queries, you can post them now in the comment section. Okay, we have our first question with Masish Bhandari. The question is, where is cache located?
So cache is another computer, basically. So if you in the diagram, when I'm showing a box, so what I'm generally saying is it's a different computer system, it's a different server. So depending on the scale of your database, sometimes the cache is in the same database, the same server. So let's try to understand the anatomy of a server, right? So when I say a server, what it basically means is, it basically means a computer. So you have a laptop in front of you. Your laptop is capable of being a server. If you put the right OS on it, it can be a server. So now in your laptop, you have, let's say for example, you play games, you play Counter Strike, you play something else. You are also using Microsoft Word, you are also using PPT, you are also using multiple different applications. So database is one such application, right, which can be installed on a server. So depending on how big your database is, you can have the cache in the same server, or it can be a different server altogether. So what you can have is, you can have a server dedicated for cache, you can have a server dedicated for your database, you can have a dedicated server for your just application code, and they will then interact with each other. So yeah, there is no one, you could say one answer fits everything, but that is how cache is. So just look at cache as a simple another database, which is just a layer between your main database. Fantastic question.
Okay, sir. So next question we have from Dushyant. The question is, what's the difference between hot backup and cold backup?
Yeah, excellent. So hot backup is generally when like I mentioned in my PPT, right? So if a backup is ready to take over the primary in case of failure immediately, that's your hot backup. So if in a you could say database system, I have implemented only one hot backup or one replica to one just one server to be running as a hot backup, or just copy every transaction, then you'll have just one hot backup. You can have multiple hot backups as well. What cold backup means is, let's say today evening or at midnight, 1 o'clock in the night, you're not going to have a lot of transactions. So at that particular point in time, you take a backup. What you do is, you look at the state, you look at the server's state, you look at the data, and you take a snapshot of it. When I say snapshot, like screenshot, right, you take a screenshot, you call it as a snapshot. So likewise, using some tools, you can take a snapshot and store that snapshot somewhere. Now let's say at 3 o'clock in the morning, something happened and your database is not up and running. So what you can do is, you can use the backup of 1 o'clock, restore it in a new server, and bring your machine back up and running. So this is a cold backup. Why? Because this cold backup had to be processed before it can be made available for use. So this is a cold backup. and a server which is ready at the second moment to take over as a main database. That's a hot backup. I hope this answers the question.
So next question we have from Shivam. The question is, can a SQL database be converted into NoSQL database? Is there any particular method?
Excellent question. So the way we looked at it, right? So relational database follows a strict, how would I put it, structure. So it requires a structure that needs to be followed. Now that same structure, now the NoSQL databases, they also follow a they also follow a kind of their own structure. So in theory, if you want to move from a SQL database to a NoSQL database, you do something what you call as ETL, right? So which is the topic of tomorrow, which I understand. So the ETL process, which expands to as extract, transform, and then load. So what you will need to do is you need to extract the data from SQL in a way that SQL database can understand, which is using SQL language, bring it to an immediate server, then change the shape of that data, change the structure of the data so that it can match the structure of your NoSQL database, and then push the data into the NoSQL. So this entire process is ETL pipeline, and this process is ETL, that is basically extract, transform, and load. So that is why there are dedicated professionals who do just ETL in real world. So it's a very complex. I mean, it is going to change from database to database. It is going to change from paradigm to paradigm. So ETL, which is working for transforming from SQL to, let's say, key value pair, is not same as transforming it to graph. So there will be a different logic every time. The logic will change from vendor to vendor. So it's a complex thing. But yeah, it is definitely possible, and that process generally is called as ETL.
So next question we have from Ankit. Sir, is AWS Storage Gateway good for backup than using the database engine on AWS like RDS?
Yeah, that's a good question. So what? Um, so the way I can explain this is, now we are talking at a very high level, right? So when I'm saying that, okay, we are taking a database backup, we are taking a snapshot. There are dedicated tools that do these things. So for example, a tool that works for Oracle database is not going to work for Microsoft SQL Server. So similarly, in AWS, you have multiple options. One of the options is using the native RDS capability of taking a backup. But if you are interested in, let's say, taking that backup and doing something else with it, let's say if you want to take it from AWS and move it to GCP, for instance, and you want to run it in a database there, then in that case, RDS backups are of no use, because those are specifically for AWS. So using Storage Gateway, you can create a backup which is non-vendor specific. When I say non-vendor specific, just non-cloud vendor specific, but still in a language, let's say MySQL understands, and put it in S3. I mean, there are multiple ways you can do it. Put it in S3 and then download it and then upload it to your Google Cloud, for example. So Storage Gateway is another way of doing it, another service of doing it.
Okay, next question is, what is JSON?
So JSON is JavaScript object notation. The simplest way I can put JSON is, let's say, there are multiple languages, right? So earlier there used to be only C, C++, but as we made progress, as we moved ahead, there were programs that were created in different language. Let's say, for example, a site like Facebook is created in PHP. So that was the language that Facebook chose to develop at that time. At the same time, any application that was written by Microsoft, it was written in .NET or C Sharp. Now there is no way that there is no common language in between these two different systems that they can talk, because .NET will not understand what PHP is, PHP will not understand what .NET is. So there had to be a common way of sharing data in between systems. So that is how initially people came up with XML. And when XML started getting uh, a little tedious and complex, which was used in SOAP protocol, and people moved towards REST protocol, JSON became the format of sharing data between two different applications. So it is a data exchange language, if you have to put
Okay, so any more questions, any more queries you may ask right now?
it. Thanks, Chirag.
Okay, sir, I think we can go ahead. If you have any more queries,
Sure.
audience, you can ask them in the next query session.
Okay, awesome. Thank you, Bor, for being attentive. Let's go to the next. Okay, slideshow from current slide. Okay, so so far we have discussed what it takes, how it works. So now let's try to understand how serverless came into place, and what is serverless, what is its effect, right? So if you remember, now let's take another minute to look at this particular slide as well. So if you are a company, if you are a startup, if you are someone who is just trying to create a new business, imagine the number of people that you need to hire so that you can run a good database cluster. So that is pretty much impossible, or how would I say it? It is pretty much very difficult for people to understand, to get these kind of people so that they can run a successful database, right? So what people like, or companies like Amazon said is, we have been running this e-commerce business for years, and to make it efficient, to make it run better, they have found ways to automate this kind of stuff. So they automated a lot of things which a hardware admin, a network admin, OS admin, or a DBA must have been able to do. So let's take that expertise and offer it as a service. So when I say service, what I'm basically meaning is, again, I'm going to use a very commonly used example of a pizza. So if I have to bake a pizza myself in my own house, I need to have everything from the pizza dough, the cheese, the sauces. I need to put it together. I need to have an oven which can bake it, which can give me that particular, you could say, effect of pizza. Or all I can do is call Domino's and get a pizza, and let them manage the dough, let them manage the flavors, let them manage the oven, right? So what I'm getting is, I'm getting the pizza as a service for a fee. So the same way, what Amazon did is, they said, okay, we have already done automating this different stuff. We already know how to run a database at scale. We already know how to make the best use of technology so that there is least amount of human intervention. Let's expose it as a service. And that is how serverless came into fruition. So what basically serverless means is, it means that hardware, network, operating system, and each everything related to running a database server is taken care by cloud provider. So in this case, Amazon. So Amazon said that, okay, let me worry about having a server. Let me worry about having a team that is going to look uh, after backup and recovery. Let me have a team looking after, let's say, network, and we will take care it for you. We will make sure that the database hardware is up and running for all the time. Sorry. And you can concentrate on your business. So that is how it came into effect, and that is how serverless databases were born. So with serverless database, what I basically mean is, if you want to run a database, you will go to a cloud provider and tell them, okay, I'm interested to run a database, please give me a database. That's it. So from the number of people that you had required, all you need is database developers and application developers, and you can have an application, you can have a database for your application. So the serverless method of delivery is, you pay for what you use, and you let the cloud provider take care of the backup, recovery, etc., etc. So it's a developer friendly way of running a database. So what does pay for what you use mean? It means like using electricity. So if this month I'm consuming 10 units of electricity, I am charged, let's say, 200 rupees. If I'm next month using 420 units, I'm charged 400 units. So there is a definition of what one unit means. So similarly, the serverless model has come up with a unit definition. So it says that, okay, if you are using this amount of, let's say, database services, that means you have consumed 1 unit of database. And for that 1 unit of database, you are paying, let's say, for example, $1, right? So that is the whole uh, simple way of putting how what serverless is, and what it what effect did serverless have. So it basically enabled the development teams to punch way above their weight. So a startup that is looking to make a business can do it with just 2 or 3 people instead of having at least a dozen people in different categories. So AWS has a big portfolio of databases. They call it as purpose-built databases. Uh, they have a database for each kind of, you could say, paradigm that we talked about. There is a relational database, there is a NoSQL database, there is cache, everything and everything. But when it comes to serverless database, these are the two prominent one. So one, from a relational database perspective, is Aurora Serverless Database, and from a NoSQL perspective, which is a key value store with some additional columnar features, is DynamoDB. Now, the way Aurora Serverless Database works is, you will you will tell them that, okay, this is the minimum amount of capacity that I need, and this is the maximum amount of capacity that I am willing to pay. So anytime your service, your application, your website gets a lot of users, Aurora will take a note of it and increase the size of your resources. When I say resources, it means CPU, RAM, storage, network capacity, to match the inflow of requirements. And with that, they will make sure that whatever requirement is coming up from your application, from your server, is always met. And when the requirement goes down, you will come back to the minimum amount of uh, capacity that you have provided. So that is how serverless Aurora works. So the way you look at a serverless Aurora is just look at it as any other MySQL or Postgres database at a very high level, but it has the inherent capacity to scale up and down as and when the load on your database, or as and when the load on your application increases. Now we have this another category of DynamoDB, right? So DynamoDB is NoSQL. It is key value kind of store. So plus with some additional capacities, which makes it a little different than key value, which we will talk about in a moment. Now, I'm not going to focus a lot on Aurora serverless because relational database is generally taught in colleges. Generally, most of the applications or projects that you do in college, you generally end up using relational databases. So you will get good exposure. At least the basics will be right when you are doing that. So let's focus a little bit on DynamoDB because that is a little different. So let's look how DynamoDB is working, right? So in this diagram, you see something called as availability zone 1, availability zone 2, and availability zone 3. Now, when I'm talking from AWS perspective, you see that, okay, AWS has a region in Mumbai. When they say that they have a region in Mumbai, what they basically means is they have facilities, three different buildings where they are distributing their servers. So ultimately, AWS is also going to have data centers or the places where they are going to keep their servers. It's just they are expert at managing them, so they do it. So what they do is they, within Mumbai region, they will identify three different buildings and distribute their resources, their servers, in three different buildings and connect them with a very high speed internal dedicated network. So whenever you log in into AWS console and you are looking, when you say in a drop down that, okay, I'm choosing Frankfurt region or a Singapore region or a Mumbai region, you are actually going to next step choose one availability zone or one data center within that region, or AWS will choose it for you depending on the service. So how DynamoDB works? So DynamoDB, the way they make it serverless is, what they have done is they have separated the storage layer from the compute layer, from the compute layer, so that you can have a different, you could say you can scale up and down as needed. So how does this help, right? Let's say, for example, you are just starting out a new business and your database is just 1 GB, and in an entire day all you're getting is, let's say, only 5 orders. So in that case, you don't require a lot of CPU. So when there is no order, you need zero CPU. If you have zero CPU and your data is intact, then it works really good for you, right? So they have separated the storage layer, they have separated the compute layer. Now, if somebody wants to fetch some details from the database, what they do is it goes via what we call it as a router. Now, a router, what it does is it uses something called as hash functions. So if you go back to your data structures class, data structures theory, we have something called as a hash function. So a hash function is nothing but a function which, if I give it a value, it's a mathematical function, it generates consistently same output. Now let's say if there is a function f of x and I gave it as an input, let's say Anurag, then it is, let's say, splitting out 1 to 3. So now, over the period of time, every time you give it Anurag, it is always going to split out 1 to 3 as an output. So that is a hash function. So what what DynamoDB does is it takes the identifier of your row, or what we call as generally as a primary key, and generates a hash of it. Now, depending on the hash of that particular value, it assigns a compute node and a storage node for your hash value. So every time you send the same primary key, it is going to generate the same hash value, and it will redirect to the right storage and compute node depending on the value of the hash. Now, when you write that particular value into your storage, or a DynamoDB makes sure that it is going to create at least two more copies of it. So every time you have written a data in DynamoDB, there are at least three different places where the data is going to reside. Okay, now this is how DynamoDB works. So in order to run DynamoDB, as we will see in few moments, you don't need to tell how much RAM you need. You don't need to tell how much compute you need. I need, let's say, 4 CPUs, 5 CPUs, or you don't need to tell them that I need 50 GB of hard disk. All you tell is I need to create a DynamoDB table, and Dynamo will do it for you. Before going into the console, before looking at DynamoDB in depth, let's look at some of the terms so that you will understand when I'm speaking about it in the demonstration. So a table is nothing but this particular picture that you see at this moment is a table. So it's a collection of data, it's a data structure, or it's a way that the data is stored in your DynamoDB. So here you see on the left, there is something called as a primary key, and a primary key has two different values. So what are those values? We'll come to that in a moment. And on the right, you have attributes. Now you will see a stark difference when it comes to relational databases. You see, if you observe very carefully in the attributes, you will find that the different items, if you look at under the column SK, we have item ID 156, 157, 158, and profile ID 10. So in these things, they are having different attributes and different values. So what does attribute mean? Attribute, you can generally relate it to as column name in relational databases, and the value is whatever value for that particular row for that particular attribute. Now if you see here carefully, for item 156 and 157, both have manufacture date, selling price, and manufacturer, but only item 156 has a category. 157 doesn't have it. So the blank space here doesn't represent anything. This is because this is the only way you can represent tables using Excel and PPT. So basically, this is a blank space altogether. Now, if you look at item 158, right, the it has the attribute of manufacturer, but it is not having any of the others like manufacturing date, selling price, category. Rather, it has its own, let's say, category and selling price, right? So this so it's totally different, the manufacturer, category, and selling price. So you can mix and match as many columns and as many values as you want using the NoSQL way of doing it. So same thing if you look at the profile number 10 row, the attributes are totally different, and there is no common attribute when you look at the top three entries. So the name, address, and customer sense is the column and value that is never present in any of these other entries in your table. So to identify this row, every row uniquely, DynamoDB uses primary keys. So this is an example of a simple primary key. You need to make sure that each entry of the primary key is basically unique for it to work. But there is also something called as a composite primary key, which we saw in this example as well. So in this example, what we have is we have the primary key is then distributed into two different parts. One is a partition key and one is a sort key. So what partition key helps? The partition key helps to is used in the hash function, so that the hash function can redirect your request to the appropriate partition in the DynamoDB, and the sort key can be used to do things like filtering, that okay, in this particular partition for, let's say, only order 001, I'm only interested in having profile, then you can do that by using sort key. So basically in SQL, or whenever you are using relational databases, whenever you so basically you can only do where clause using the sort key. So this is a limitation of DynamoDB at this moment, or that is how DynamoDB basically works. The each entry that you make in a DynamoDB is called as an item instead of, and the equivalent of that in relational databases is a row. And we already talked about attribute and attribute values, right? So I'm going to stop the share, and we are going to look at a quick and small demo and slideshow. Now I'm going to go to my console, share screen, and share. So here I am in my management console, or how the AWS management console. So let's do one thing. Let's start with DynamoDB. So let's try to create a very small DynamoDB table. So what you can do is you can look at all services. In all services, search for database, and in database you will find DynamoDB here. Or you can just go here up and just say DynamoDB. Oh, sorry about the spelling mistake. I'll just click on the DynamoDB here. Come on. Okay. So let's give it a moment, and the DynamoDB screen will come up. Okay, so this is how the screen looks like. So what I need to do is I need to I clicked on the wrong thing. Okay, I'm going to click on our DynamoDB. Okay, so here is the DynamoDB screen. So I do not have any DynamoDB tables at this moment. So let's try to create a table. So if I hit create table, it is going to bring me to a screen. So if you're now if you have carefully observing it, right? So it did not say create database. It is saying that you need to create a table. So if you remember, in serverless way, you are not creating a database as such. You are consuming the service. aws is taking care of the database, aws is taking care of the servers. So all you need to do is you need to specify and be very specific about just your business logic. You don't need to worry about which server is created, where it is created. So in DynamoDB, what you do is you create a table. So for this example, let's continue with the example that we saw in the PPT. Let's say I'm going to call this as my orders for, let's just say business. Sorry for the spelling mistake. Business X. So this is my name of the table, or this is my business, right? So now here what I need to do is, if you remember, we need to create a primary key, and now primary key has two options. You can create a partition key as well as sort key. Now if you remember, partition key is used by the hash function to determine where, in which storage node, in which compute node your data needs to go. And sort key is used to filter the values that are present inside that particular storage node. So each storage node typically in DynamoDB holds up to 10 GB of value. So when the 10 GB exceeds, it is going to put the data in another node. So this way they make sure that okay, that every node is going to have only 10 GBs of data, so that it will give you a consistent performance. So let's say business X, let's say our partition key, I'm going to just call it PK, for example. And now what I can do is I can specify the data type. So it can be string, binary, or number. Let's stick with string. I'm also going to say my sort. I'm so sorry about that. I'm going to say sort key is SK, and I'm going to keep it as string. So now here you see it says that, okay, I want to use default settings, or if I uncheck it, then I have the options of defining more things. Now, if you remember when I said that, okay, you can do filtering only by using, or basically you can run a where clause only on your partition key plus sort key, right? But what if your application requires more ways of running it, right? More ways of doing it, more ways of filtering the data, more ways of searching the data. So in that case, there is something called as secondary indexes that you can use to create additional query patterns. And using those additional query patterns, you will be able to mimic more and more access ways of accessing the data. So we are not going to use secondary indexes for now, because this is a fairly complex topic for beginners. So we'll skip the secondary index for now. And now here is what we called as read write capacity mode. So now this is how the billing works for your DynamoDB. So if you remember, if I said in the beginning that, okay, you are not being built for provisioning the server. So so in relational databases or in traditional way, even if your database is receiving 0 connections, and let's say if you have spun up a 2 GB RAM and 40 GB hard disk of a server, you are going to pay for the entirety. But the flexibility with DynamoDB is you don't need to do that. You need to just specify to DynamoDB that, okay, I am expecting that there will be 100 reads and 50 writes per minute in my server, and that is the capacity that I need. So depending on how much capacity you provision, how much capacity you use, your bill will get affected. So if you are using just simple, if you are putting it on provision mode, and you are in provision mode or in on demand mode, sorry, let's take a step back. So for billing we have two modes, one is provision mode and one is on demand mode. So what provision mode means is, it means that you know how your application is behaving, you know that you won't have, let's say, x more than x amount of transactions per day or per minute. Then you can look ahead and just say that, okay, I need 100 reads, 50 writes, for example. But if you are a new application and you don't know how your application is going to perform, you switch to on demand mode. And using on demand mode, the algorithm for DynamoDB basically will determine the best read and write capacity. It will scale the capacity up and down as per the requirement. So for the sake of the demo, so that I don't get billed a lot, I'm going to say provision mode because it's free tier eligible. And using the free tier eligible, now the free tier eligible will say that, okay, you can have 5 read capacity units and 5 write capacity units. So basically what it means is, write you can read 5 transactions per second, you can write 5 transactions per second. So this is the basically the read capacity unit and write capacity. There is a big mathematics that goes behind this entire thing, which is too complex to cover at this moment. The same thing is taken care by the auto scaling capacity. So within this, with using this auto scaling capacity, you are basically trying to tell Dynamo that, okay, if my read capacity, if a CPU is hitting, let's say, 70%, and then the minimum amount of unit is 5 for me, you don't exceed below let's say beyond 40,000 units. So with that way, you can make sure that you are not having a big bill, right? And Same thing applies for write capacity, and then you can do encryption at rest, which is the if you click default, DynamoDB will take care of it. If you want some other application to take care of that encryption, then you can bring your managed own key, or you can use KMS. So for the sake of demo, we are going to use default settings for this moment. And using the default settings, what you can do is you can just hit on create. All right. So that's as simple as that. It is. It will take a couple of minutes, and it will then create a table called as business X. Right. So now the business X table is basically ready to use. So now, how do I know what the data is? So the terms that I introduced to you called as items. So items is nothing but the number of rows that you have in the table. So right now in this particular table, you do not have any data. So let's say I want to create an item. So I'll create an item. Here you need to specify PK and SK. So let's say the partition key is business. If it is business X, then now let's say for X, my first partition is for first business is, let's say, biscuits. And in that, the sort key is, let's say these are sweet biscuits, right? And now I want to have additional, you could say, additional columns and values. So I can say append string, and you can give a column name and a value. Now let's say I'm going to say brand, and I'm going to say let's say Parley. Then I can again say append, and let's say string. Now you can choose multiple data types, but I'm just going to go through quickly with strings because it is easier to. And I will say, let's say sub brand, and let's say it is it is Parle G, or you could say just call it as glucose, right? And that's it. So this is my item that I have created, and it will create a new entry, which is a row or an item inside this particular table. Now let's say I want to create another row. Right now, the primary key, instead of business, I have a business of masalas. I'll say masala, and the sort key is, let's say, garam masala. Now I can append more things, right? And now I can say here manufacturer, and this is, let's say, MDH. And what is the type? Let's say it is kitchen key. I'm just taking random examples for the sake of it. And save. Now if you see, now observe clearly here, right? So we have had different partitions, we have created two entries in this database, in this table, but this entire two table, you could say, entries differ in the way they are working, right? So every time there is a f of x of, whenever there is, when I, now let's say if I do an action and I want to, let's say, query, right? If I want to query this database, now of course, when you're writing this queries, you're not going to write it on the console in the application. In the application, you do it via the SDK or the methods of that particular language that you're using, where you can specify. Now here you see, you have to specify every time the partition key that from where you want to fetch the data. Now let's say, before going into this, let's try to create another couple of items. So I'm going to create everything, another one for biscuits, and instead of sweet, I'm going to say salty. I'm going to append a couple more columns. I'm just adding some data for our demo, so don't worry about it. So manufacturer, it's again, let's say Parley, and let's say sub brand is echo and right, and I'm going to create another entry for masala, and I'm going to see call it as, let's say, chat masala, and I'm going to create rows in menu facture. I'm going to say it is Shaha, and the type, I'm going to give it a type and call it as chat masala, again chat masala, and click on save. So now we have four entries, two for biscuits and two for rows, two for masalas. So let's say now I in my application I want to know that, okay, what are the what are all our biscuits that I have in inventory. So here you see you have two options. One is scan and one is query. So scan is like, if you use scan, you should generally avoid using scan, because scan means that if you have, let's say, 10,000 items in your table, then it is going to go in each table and try to find that particular value for you. So in order to make sure that your read capacity unit and write capacity units are in order, you should always use a query. So in query, you need to always specify the partition key. Here you see there is no options for me to choose. So let's say I'm interested in biscuits, right? And if I see keep biscuits and I don't provide sort key and start search, it is still going to give me all the values. So by basically what it has done is it has looked for the partition where there is data for all the biscuits, and it has given me back. Now let's say I am only interested in salty kind of biscuits, right? So what you can do is you can manipulate the data by using the sort key. So using the sort key, you can say it is equal to, less than, greater than, equal to. Of course, these are going to apply for the right data types. Now let's see, if I say that it begins with SW, right? So and click on search, so it is going to search on suite. It is using sort key to make a search on suite. Now instead of biscuits, I can also do as masala, and if I try to do a search now, it is not going to return me anything, because this something like this sort key is not available. And if I click on remove it and still search, it is not going to search it, because it is looking for that particular string. So now scan, if you want to do scan, you generally do scans on top of attributes when you don't know uh, uh, the primary key and sort key structure. But generally speaking, 99% of the time you should never use scan, because like I mentioned, if your table is, let's say, 100 GBs, then a scan will go and visit each and every item in your table to get those particular values. So it's a very expensive affair. It is going to consume a lot of read units for you. So this is a very uh, brief way of using DynamoDB. And here you see in DynamoDB, if I want, I can create another table. So you can have another table for your another business, and so far and so forth. So basically in DynamoDB, you can have multiple tables, and each table is an equivalent to your one application. So I'm going to delete this table because I do not need it anymore. Our demo is complete, and click on delete. This was all about a brief introduction of DynamoDB. Let's quickly look into Aurora Serverless. So for Aurora Serverless, what you need to do is you need to go into services, go into database, and you will find Aurora Serverless actually in RDS. So why RDS? Because it is still relational database service, right? So so I've clicked on RDS. Let the screen come up. Takes time. Okay, here we go. So as you see in DB instances there are 0. So I'm going to say and click create database. Now, when I clicked on create database, it will bring up a screen, uh, and here you see you need to choose an engine type. So in this engine type, there is Amazon, Aurora, MySQL, MariaDB, Postgres, Oracle, Microsoft SQL Server. We are interested in Aurora, and let's say I'm interested in PostgreSQL. So what Aurora is basically, what they have done is they have taken the code base of MySQL and Postgres and enhanced it a bit. So it's a kind of a fork or something that has been built on, I'm sorry, on top of MySQL and PostgreSQL. So if I choose on PostgreSQL, for example, then you will see that there is two capacity modes. One is provision mode and one is serverless mode. So the provision mode works the way the traditional databases works, but the serverless mode is what we discussed. So in the serverless mode, you need to choose a version. So right now, unfortunately, only one version is supported for Postgres, which is Postgres 10.12. And then you need to specify the settings. Like, let's say, what is the name of the cluster? Let's say LPU demo is the name of the cluster. What is the settings? So here what is the master username? So I'm going to say the master user is Anurag Kale, for example, and I'm going to say uh, you can auto generate the password, so that Amazon RDS will generate the password for you, right? Or you can specify the own password. So for this moment, I'm going to say I'm going to create my own one, master password. It needs to be at least 8 characters, single quote, and all that stuff. So I'm going to write a password which matches their criteria. This is the master user, or this is your, you could say, uh, admin user. Now here you need to specify what is the minimum Aurora capacity unit and what is the maximum Aurora capacity unit. Okay, I think I made something. Okay. It's working fine. So you need to specify what are the minimum Aurora capacity units. Let's say I want to start with 2, and what is the maximum Aurora capacity unit that you want to have, right? So let's say, for example, my I know the limitations of my application. Then I'm going to say that, okay, I don't need anything more than 16 GB, for example. Now how do you know that your application will need this? It comes down to your design. It comes down to how many customers you have and how your application is behaving, right? And then you can have, for you could say something like additional scaling options for scaling and pause the compute capacity. But it's fairly advanced topic, we'll keep it aside for the moment. You can launch this particular database in a VPC. So VPC, if you don't know, it is like creating your private network within AWS, so that any other AWS service, any other AWS user will not be able to infiltrate in your network. So for this moment, I'm going to just keep the default VPC, because I'm going to delete this database and I'm not going to do anything else. And you need to choose the security groups. So security group is basically the first firewall that you require on the database authentication here. And then finally you say just create database, and that's it. That's basically how easy it is to create a database in AWS. Now how you use the database, what is the application of the database, it totally depends on your application, your use case. But this is how easy AWS makes it for the builders to create a database in your, you could say, for your applications. So it will take some time. So you see that the status is creating here. So it takes couple of minutes to create your database cluster. And once you connect, so how you can connect with to this particular database, like you connect in any other relational database. So you specify the link to your database. You specify the username and password, and then your application will be able to connect to the database. Or you can use a tool like MySQL, Postgres, the desktop tools to connect to your database using those credentials. Uh, so that's about it about the serverless databases that we have to cover today. Uh, I know we have touched based on couple of important topics, um, but this is a base that I wanted to give you so that you can go ahead and explore the world of serverless databases. So I'm going to share the screen again for one brief minute, and then I'll be open to your questions. So I hope I did not do a lot in demo because we were trying to cover the basics, but yeah, now that's the conclusion from for our today's session. You can, if you have any questions, if you want to ask me something, you can find me here. I'm pretty active in Twitter and LinkedIn, and I will take any questions that you have at this moment. Over to you.
Sure, sir. So let's have the Q&A session. So first question we have from Lakshay. The question is difference between synchronous and asynchronous transfer between read replica and master DB.
Okay, that is a good question. So basically, synchronous and asynchronous replication. So let's talk about replication first, so that people who don't know about replication can understand. So if you remember, when I described the anatomy of databases, I said that whenever there is a backup, right, you are always copying the data which is written in the master to your hot backup. So this process of copying the data over from the main database to the secondary database, or the failover database as they call it, is called as a replication. So now when there is a synchronous replication, that means that the moment there is a transaction, the moment there is a data in main DB, the same instant you make a copy to another database, that is synchronous transfer, right? So it waits for, basically when you make a copy, it will wait for an acknowledgement from the secondary database that okay, I have received the data. So this is synchronous. So basically the both parties involved in the data replication are saying that okay, I have sent you the database. First party will say I am sending you the data. Second party, okay, I have received it and the data is fine. So they are communicating with each others to make sure that the data copy is happening. So this is synchronous transfer. What is asynchronous transfer? So the asynchronous transfer is when uh, your primary will, let's say, hold 15 transactions and just split it out to your secondary, and it is not waiting for your secondary to respond back, or it is not basically uh, copying each transaction every time. So it might cache, or it might keep some transactions in uh, queue as such, and then copy it over and just send it to the processors, or to the consumers, as we call it, downstream places where it can consume that particular data. So that is uh, asynchronous transfer. When it comes to the specific question that from master DB to read replicas, is the replication synchronous or asynchronous? It depends on the engine. It also depends on the offering. So in traditional RDS, I I'm not sure. I completely remember at this moment, but I think that copy is synchronous. I could be wrong. I'm not remembering the details, but this is how you can differentiate between synchronous and asynchronous. But these details are easily available in the documentation for that particular region.
Okay, so we have a next question from Mohammad Sami. The question is while planning our DB's architecture, how can we be cost efficient?
Yes, so that's the whole point, or that's a question that has been eating architects for many years. And this is one of the questions which led to the invention of serverless database, basically. Because if the serverless databases, if you remember, in DynamoDB there was something called as an on-demand mode or something called as provision mode as well. So in on-demand mode, what you basically said is, let us figure out how the application scales, and then we will come to know that this is the capacity that we need, and then you can provision that. So what generally happens is on-demand mode is little costlier than the provision mode. So what you can do is, typically what people do nowadays is they run the application for a month or two in on-demand mode and look at peaks and look at how the data is performing and when you are getting the more requests and all that, and they will average out that particular credentials, sorry, average out those findings, and then switch that DynamoDB from provision mode to on-demand mode for the peak. So this is how you make sure that you have the cost efficiency in place. But the cost efficiency is the very fundamentals of why serverless database came into picture. So if you, again in Aurora as well, so you said that okay, the minimum capacity is 2 ACU or Aurora cost units, but the maximum is, let's say, 64. That means if my application is having less load, I'll end up having less bill. But if there is a surge, then the bill will increase, but that will increase only for the time that there was that particular peak. Then it will come back to normal. So there is no standard way of answering this question, because it's a highly debated, highly uh, how would I put it, a highly researched kind of topics between the architects to trying to find the sweet spot where they begin. But the strategy is, again, starting right from on-demand mode, then looking at it for a couple of weeks, couple of months, and then moving to provision mode generally helps.
Okay, sir. So next question we have from Ashutosh Mahapatra. The question is, does Amazon DynamoDB support both increment and decrement automatic operations?
So I'm not exactly sure what increment and decrement atomic operation means, but if we just look at atomic operations, right? So atomic generally means, generally is a term that comes with your ACID principles in RDBMS. And unfortunately, because DynamoDB and as well as Aurora Serverless, these are distributed systems, so they generally do not adhere to the ACID principles. So getting, strictly speaking, you don't get atomicity in DynamoDB, but there are ways to work around for this. For example, let's say if you want to combine multiple transactions as a single atomic transaction. So let's say, for example, a bank transaction, when you say if you are withdrawing some money, that means if you're transferring some, let's say, from a person A to B, the transaction is only complete when money is subtracted from A and added to B. And if one of these does not happen, then the transaction has to be, the entire thing has to be unsuccessful. So you can club these kind of transactions in a transaction API call in DynamoDB, thus giving you a little bit of ACID kind of compliance. But strictly speaking, the atomicity side of ACID is not generally followed by any distributed system, and DynamoDB and serverless just happen to be two of the distributed systems in this world.
Okay, sir. So next question we have from Shivam. The question is Redis faster than DynamoDB?
Okay, to answer this question, Redis is a brand, and Redis has multiple offerings inside that. Redis Cache is one of their offerings, which is quite famous, but there are multiple offerings from Redis which can do what DynamoDB does, which can do different things from different paradigms. So assuming that he's referring to Redis Cache, generally caches are always faster, but cache also has a limitations that you only have a key value fetch. So you need to have a key, and whatever value is present in that particular value, your application is supposed to process it. You cannot do filtering, you cannot do where clause and all that stuff in the cache, right? So just giving a context, yes, Redis cache will be faster than DynamoDB, but that's the nature of cache. That is how cache is supposed to work. DynamoDB has its own cache called as DAX. So if you combine DynamoDB with DAX, you can get comparable results of Redis cache.
Okay, sir. Next question is from Dushyant. So serverless will be specific to cloud provider, then will there will be any issue while migrating?
Yes, so serverless engines, or the way the data is stored by these engines, is always vendor specific. So the way DynamoDB stores data is totally different from, let's say, for example, in Azure, there is a comparable service called as Cosmos DB. So in principles, they work quite same, but the way the engineering is done behind the hood, because we don't get to see how it is functioning behind the hood, everything is abstracted away from us, so you don't know how they are working. So it is as equivalent as saying that, okay, I want to move data from MySQL to SQL Server. So MySQL is one relational database, SQL Server is another relational database. Although in reality they are both relational, but the way the vendors have implemented, MySQL is open source, SQL Server is Microsoft implemented, they could be different. So there will be some changes. Yes, there will be a uh, the way the industry uses the term is lock-in. So if you are using DynamoDB, you're locked to use DynamoDB. But again, if you are desperate enough, you can use ETL and fetch data from DynamoDB and convert it into a, you could say, convert it into a method or convert it into a form that other DB can accept that data.
Okay, sir. So the next question is from Tushar. Which AWS service can we use for storing big data?
So big data is an umbrella term. It's not. It's not like we can call one database as a big data database and another database as not. But to facilitate big data kind of thing in AWS, we have something called as AWS EMR, which you can use to run Spark, Flume, Splunk kind of workload, which are generally the tools that fall into the big data world.
Okay. So I think we have our last question in the list. The question is from Jayesh Paliwal. Does DynamoDB support in place atomic updates?
I think it doesn't, because it is a extension to the same question that we have uh, I had a few minutes ago, that whether it is atomic. So no, strictly speaking, DynamoDB is not atomic because it is a distributed system, and it adheres to what we in theory what we call it as CAP theorem. So CAP theorem stands for consistency, availability, and partition tolerance, right? So CAP theorem says that in any distributed system, you can only have two of these three vertices. So you can either have, let's say, consistency plus availability, or consistency plus partition tolerance, or partition tolerance plus consistency. Just the you could say combination of these two things. So what DynamoDB does is it has chosen uh, to choose the vertices of availability and partition tolerance. So the consistency is eventual in DynamoDB. So when I say eventual, what it means is I mentioned in DynamoDB that if I want every time I create a data, there are at least two more copies of this data. So this data, if it is going to other partitions, right, the uh, the write will be consistent after certain amount of time. It won't be consistent. It won't be written immediately. So there is a chance that if there are multiple applications trying to read from that particular partition, before a new data is written, you might get stale data from one of the partitions. This is because DynamoDB transactions are eventually consistent. But there is a workaround for this. So there is something called as a consistency parameter when you make a request from AWS, when through DynamoDB SDK, and with that you will consume a little more read RCUs or read control units, but you will get a consistent read. So strictly speaking, no, but there are workarounds for atomicity in DynamoDB.
Okay, sir. I think we have no more questions from our audience. So
Thanks.
thank you so much for an amazing presentation and Q&A session. I personally enjoyed it and got to learn so many new things. And I must say your teaching methodology is really great.
Thank you.
And I hope the same for our viewers. So today's session must have made you familiar with AWS platform, serverless database, Aurora services, and DynamoDB. So let's know about your experience in the comment section, everyone. Sir, I would like to ask you, how was your experience today with our community, with this platform?
It's an incredible platform. So I genuinely believe that we need more of this, because we talk about bridging the gap between academics and industry, and there is no better way than doing it in this way, so that people who are working in industry can come in and pitch in new details, so that you have the time to go and explore the new technologies, learn in the process, make mistakes. So the very important thing that we generally do not push in our academics is mistakes. Mistakes are generally frowned upon, but I encourage that. Look at what I have. I gave you the basics. Now, what I will ask people is, go to the internet and search for cloud resume challenge. Right, what I'm going to do is I'm going to put it in private chat so that you can forward it to people. It is called as cloud resume challenge. Right, so I've just put it in chat. You can relate across to the users. So what it does is, it is giving you a simple uh, project in which they are asking you to create a resume for yourself using AWS services, and it uses DynamoDB in the backend. This challenge has listed out the steps that you need to do, and it has been created by one of the members of a Cloud Guru community or a Cloud Guru company, who are AWS basically cloud training people. So take the time, look at the cloud resume challenge, try to create a resume in as a website. So in this process, you will learn DynamoDB, you will also learn AWS, you will also have a way to tell your potential employers, as well as people where if you are seeking internships, that okay, please look at, this is my website which I have created using AWS. So nothing like showing your work and asking for internships, rather than just showing a piece of paper and telling that okay, I can do this. So this is the key takeaway that I want the students to take from this, that use this as a baseline, use this as a starting point, explore more what DynamoDB can do. Main thing is, because there is free tier and your institute is affiliated as student partners, you get credits. Build things on AWS. Let them, even if they are not going to be used, let's say 6 months from now, 2 months from now, that is fine. The process of building is what is going to teach you more than the end product itself. So yes, I would say this is this is a fantastic way of bridging the gap between academics and uh, industry, and it'll bring a much mature work audience, a much mature work force once you people graduate, given that of course you need to do the work that it needs.
Thank you, sir. I think we have our one more question from audience. The
Mhm.
question is Ash Paliwal. What are the opportunities in Amazon for web developer looking for internship?
Right. So web development, again, it's a very big umbrella term, right? So web development, if you have to look, is if you are building anything for the web, that is web development. So if you are building websites, if you are building applications, software as service applications, let's say for example, a good example of software as service is Gmail, right? So that is to do any of this, you need somewhere to host. You need resources where you can put your application code. That is where AWS comes into picture. So build any project, right? Let's say for example, talk to your peers. Let's say you people are struggling. I'm just taking a very crude example. Let's say you people are struggling with time management. Can I create a simple drag and drop application that can help people create a good schedule and manage their time? If I create that using web service, if I can create that using let's say React, Angular, Python, Node.js, and host it on AWS, and let's say expose it to the internet to use for your friends, that is nothing but web development. Amazon is going to help you host those applications and bring it over to the internet. So what is the opportunity? I would say cloud is the thing. Cloud is the way going forward, and everything related to applications is going to be on cloud in next couple of decades.
The next question we have from Brahmajit. How to build career in cloud? I am a fresher.
That's an excellent question. And what I've done is I have thought about it and written about this particular question in depth for quite some time. Let me do one thing. I am going to plug in a link. I have written a big, uh, how would I put it, blog post on this data. Just one moment. I just need to find.
Sure, sir. Take your time.
Yes, got it. So I have put it in the chat. You can relay it ahead. So I have written an entire post on it, so that what are the different methods, what are the different ways you can look at uh, exploring AWS that will help you basically take the first step, get some experience. Again, very good method is doing this cloud resume challenge, because it will not only expose you to AWS services, it will also give you a way to showcase your own experience to potential employers in the process of building a portfolio for yourself using AWS services.
Okay, the same question, I think similar question we have from Ashutosh. I hope you are clear. Okay. Any more questions, audience? Thank you, sir, for such a great and amazing session and this most
Yes.
interactive Q&A session. Uh, Thank you, sir.
Awesome. Have a nice day, guys. And if you have any questions, you can reach out to me on Twitter or LinkedIn, and I'll try my best to answer as many questions as I can.
Yes, I hope our team has already shared the LinkedIn ID for you.
Yes. Awesome. Thank you,
Great.
everyone. Bye bye. Have a nice evening.
Thank you, sir. Good evening. Good. So that's we are at the end of the session. So I want to thank our speaker, Mr. Anurag Kale, sir. Thank you so much for making us aware of this AWS platform. And at last but not the least, I would like to thank the entire AWS Cloud community for joining the session, and also our viewers. Thank you for being connected with us. We are at the end of today, but this is not the end. We have another engaging and informative day coming on 20th April 2021 with Sashank Mishra sir. I would request our team to kindly drop down the feedback link. I think they have already done. All the attendees must fill the form correctly, and as the certificate will be provided by using these details only. Or you have to fill the form within 30 minutes. So make sure you fill it correctly as soon as possible. You can follow us on our social media handles. To make it easier for you, our team will be sharing the tree link in the chat. If you have any queries, you can either mail us or DM us in our official channels. We would be there to help you out. And the most important thing, everyone, as Corona is spreading rapidly, so kindly take necessary precautions and stay safe. Take proper care of your health. With this, we come to the end of the today's webinar. Thank you so much. This is your host, Arush Nigam, signing off.